Washington debates the role of artificial intelligence in American life. China is racing to incorporate it across society.
In a Beijing showroom, an engineer peels the protective film off a bipedal robot the size of a tall 10-year-old. The price tag reads $13,500. A few weeks later, that number detonates across Western technology journalism. Headlines declare the United States is 100 years behind. Wall Street demands answers. American robotics CEOs schedule emergency board calls. The figure becomes shorthand for a generational defeat. The hardware is real. The price is real. A Chinese teardown by Zhongyu Securities pegs the actual manufacturing cost at roughly 41,600 yuan, around $5,800. The retail margin is 40.7%. This is not a subsidized loss leader. This is a high-margin, structurally sound consumer product. But the real story is what that $13,500 price tag actually buys, and what it doesn't, and whether the metric being used to measure the gap is even the right metric. Welcome back to the channel. We are going to walk through the humanoid robotics race the way it looks from the strategy desk, not the way it looks in the headlines.
After dominating the electric vehicle market, China's supply chains have now turned their attention to something new: the humanoid robot.
The argument rests on three claims. First, that the Chinese hardware advantage is structural, not promotional. Second, that the United States is losing a competition it did not realize it had entered. Third, that the price gap will compound into a data gap, then a software gap, and then into a market that does not come back. We grant that the Chinese lead in physical hardware is real, and then we will show you why 100 years is the wrong number, and why the part of this race that matters most has barely started. Start with the hardware. The Unitree G1 entry-level model sells for $13,500 in China and roughly $16,000 internationally. 23 degrees of freedom, walks at 2 meters per second, ships with a Livox 3D LiDAR and an Intel RealSense depth camera. The educational variant scales to 43 degrees of freedom and adds an NVIDIA Jetson Orin module. Engine AI undercuts Unitree at $12,000. Booster Robotics enters at $29,800. 3 Chinese firms now sell functional bipedal humanoids below the price of a mid-sized sedan. Now the manufacturing math. The Zhongyu Securities teardown isolates 27,500 yuan in joint actuators alone, 14,000 in components and compute, 3,000 in processing. Total cost, 44,600 yuan. Selling price, 75,200. Gross margin, 40.7%. Unitree's filings show company-wide gross margins rising to 59.8% in early 2025, even as average selling prices fell from $85,000 to $25,000. The unit economics are structural. Then, the volume. IDC and Omdia estimate global humanoid shipments at 13,000 to 18,000 units in 2025. Chinese vendors accounted for roughly 90%. Omdia ranked Agibot first with 5,168 units. Unitree disputed the number, claiming over 5,500 shipped, $248 million in revenue, and projecting up to 20,000 deliveries in 2026. Agibot crossed its 10,000th mass-produced robot off the line in April. UBTech produced roughly 1,000 units. The fight is over which Chinese firm leads. Wang Xingxing, founder of Unitree, has stated publicly that humanoid robots built in China should run faster than human Olympic sprinters within the year. Peng Jihui, co-founder of Agibot, frames it this way, quote, "Embodied intelligence is no longer a concept, it is becoming a new form of productive infrastructure," end quote. Now the systemic gap. In 2023, the United States installed roughly 44,000 traditional industrial robots. China installed over 300,000. A McKinsey analysis from late 2025 modeled what it would cost to build a Tesla Optimus Generation 2 using only non-Chinese suppliers. The bill of materials inflated threefold, from approximately $46,000 to over $131,000. The actuators, LFP battery cells, precision bearings, LiDAR, camera modules, the entire physical stack sits inside Chinese supply clusters in Shenzhen and the Yangtze Delta. What China built is not an accident. It is a deliberate transposition of the playbook that captured the American EV and commercial drone industries. In 2023, China's Ministry of Industry and Information Technology issued a formal roadmap declaring humanoid robotics a, quote, new engine of economic growth, end quote. By 2025, China would establish secure domestic supply chains. By 2027, China would lead the global humanoid sector. Shenzhen, Beijing, and Shanghai allocated municipal subsidies. The Lingang Intelligent Manufacturing Park opened as a dedicated humanoid industrial zone. State capital flowed into actuator manufacturers, battery cell producers, and LiDAR suppliers. Actuators, motors, gearboxes, and encoders represent 40 to 60% of a humanoid's bill of materials. Western platforms historically used expensive linear actuators or low-volume harmonic drives. Unitree designs and builds its own permanent magnet-synchronous motors in-house using rotary architectures. The rotary joint sacrifices precision under heavy industrial loads, but it is dramatically cheaper to mass-produce. Agibot, Roboterra, Fourier, Engine AI, and Booster pursued similar strategies. The component cost collapsed. In May of this year, Chinese regulators released the country's first comprehensive policy framework for agentic AI, treating intelligent agents as physical infrastructure. Beijing is preparing for widespread public deployment of embodied robots within the decade. The price is one effect. The data flywheel is the consequence. Embodied AI foundation models, the neural networks that allow a robot to see a kitchen, identify a coffee mug, plan a grasp, and execute the motion, require enormous quantities of real-world physical interaction data to train. The party with the largest deployed fleet wins the data competition by definition. By pushing thousands of sub-$20,000 humanoids into research labs and commercial pilots, Chinese firms are building the largest physical interaction training corpus in the world. Agibot has already published an open-source robotics dataset. Magic Lab's Magic Mix World model relies on continuous real-world feedback. The hardware layer is generating the data layer. The data layer feeds the model layer. American firms still dominate the cognitive layer. The vision language action models, foundation models from Google DeepMind, OpenAI, NVIDIA, and Tesla. But that dominance improves through training data. If China generates more training data by an order of magnitude, the American advantage is a depreciating asset. Andreessen Horowitz partner Martin Casado wrote earlier this year, quote, "The country betting on that future is China, not the US," end quote. That is the threat case. Here is what the headlines skip. First, the price stratification. The $13,500 Unitree G1 is not a working industrial robot. It is a developer kit with 23 degrees of freedom, basic grippers, and a 2-hour battery. The research tier G1 EDU costs upwards of $70,000 after import duties. Comparison to a fully equipped Aptronic Apollo or Agility Digit is comparing a base trim sedan to a freight truck. Second, the software exclusion. The G1 ships with a Python SDK and ROS2 compatibility. It does not ship with autonomous facility mapping. It does not ship with warehouse management system integration. It does not ship with safety-certified human collaboration protocols. It is a remote control toy you have to teach to do useful work. Agility Robotics charges upwards of $250,000 per unit because they deliver an integrated robots-as-a-service deployment that performs commercial work on day one. Third, demonstrations versus deployment. Unitree generated viral coverage at the Lunar New Year Gala with 24 synchronized robots performing kung fu routines. Independent footage from the Beijing Humanoid Marathon a few months later showed multiple Chinese commercial models overheating, suffering gait instability, and walking with visible imbalance. Many manipulation tasks in Chinese promotional videos are executed through human motion capture teleoperation, not autonomous AI. Fourth, the actual industrial deployments. The Figure 02 completed an 11-month deployment at the BMW plant in Spartanburg, walking 1.2 million steps and handling over 90,000 precision sheet metal components across the production of 30,000 BMW X3 vehicles. Aptronic Apollo operates inside Mercedes-Benz facilities. Agility Digit is in live deployment at Amazon and at Spanx through GXO. Boston Dynamics has committed its entire 2026 Atlas production capacity to Hyundai. Tesla operates over 50,000 internal Optimus units across its own factories. The verifiable industrial deployments are still overwhelmingly American. Fifth, the safety paradigm. A 45-kilogram bipedal robot performing erratic limb movement during a balance recovery panic is a kinetic hazard. Chinese platforms have demonstrated that failure mode in independent stress tests. American firms pursue rigorous safety certifications because their commercial customers require it. Without them, no Western automaker will sign a production floor deployment contract. Sixth, the AI software gap is wider than the hardware gap. The cognitive layer, vision language action models, NVIDIA, Isaac Lab, and Omniverse the multimodal foundation models, is overwhelmingly concentrated in American firms. Google DeepMind, OpenAI, NVIDIA, Tesla, and Boston Dynamics Atlas program with Gemini Robotics integration. The physical robot is, in McKinsey's words, a vessel for a neural network. The most advanced vessels today are mostly empty without American foundation models inside them. And seventh, the deployment economics. A loaded warehouse worker in the United States costs $30 to $45 per hour fully burdened. The operating cost of a humanoid runs roughly $6 to $12 per hour. At a $30,000 purchase price, the payback period in an American facility is 4 to 8 months. In China, where warehouse labor runs $6 to $8 per hour, the same robot takes 18 to 30 months to pay for itself. The country with the cheap robots has less reason to deploy them. So the honest answer to whether the United States is 100 years behind China is no. The actual deficit is structural but bounded. On one road, the Chinese hardware lead compounds. The data flywheel turns. The thousands of low-cost units generate training data at a rate no American firm can match. Foundation models trained on that data close the cognitive gap. Chinese platforms add the software layer they lack, integrate the safety certifications they skip, and arrive at the global enterprise market with a credible product at a price American firms cannot meet. Within 5 years, Chinese platforms own commercial humanoid robotics, the way they now own commercial small drones. On the other road, American firms convert their software dominance into commercial lock-in faster than the Chinese hardware advantage can convert into software. Tesla scales Optimus to commercial sales. Figure ships the Figure 03. Apptronik scales Apollo through the Jabil manufacturing agreement. 1X ships the Neo at the same $20,000 price point as the Unitree G1, but with a fully integrated home deployment software stack. Boston Dynamics delivers Atlas to Hyundai. The countries that need labor automation most, the United States, Germany, Japan, South Korea, buy from American suppliers because their labor markets reward verified safety and autonomy more than sticker price. The actual measurable gap is a 3 to 5 year deficit in hardware manufacturing on the American side, juxtaposed against a 1 to 2 year deficit in software and foundation models on the Chinese side. That is not 100 years. That is 2 industrial monopolies pointed at each other across a contested middle. The race is real. The metric is wrong.